Oh, okay. We're working now. Okay. Folks, we think we figured out how to solve this problem, which is to move closer to the building where the event is being held. And we should be active now a little bit further away from where the rest of the action is taking place on site here today. Um, okay. So I think we'll be able to do some stuff, and I'm just going to go get my colleagues, and we'll be back live in a minute. Yeah, we were trying to do it over there, and the Wi-Fi wasn't good enough over there. So yeah, um, yeah, and we're gonna catch up on your video. All right, so now we're back, and we should be able to show you some stuff as the day goes along. Um, okay. All right, and I'm about to share some video from Exploratorium's telescope here in Junction. Okay, so this is what we're seeing from Exploratorium's telescope here in Junction, Texas. And you can see that the sun is about 50% eclipse here. And thanks very much to the TTU Lana River Field Station staff for helping us set up and move over here. All right. And I think we're successfully live streaming the eclipse now. I think the internet connection is a little bit jumpy here, but we're able to do something. Okay. All right. So are you ready to say something? So, Diana, maybe you can say what
Maybe I can
folks
sit
are
down.
seeing here. Oh, yeah, yeah, that'd be great. Yeah.
Okay. Hi, everybody. So here we're all catching our breath. We're all catching our breath after this quick trot across the field to come closer to the Wi-Fi. And we have right now, I would say the solar disk is about 2/3 covered by the disk of the moon, the silhouette of the moon. And we have a lot of excitement happening. People are, I think the light's beginning to dim visibly.
Yeah.
Wouldn't you say,
Yeah,
Tom?
I think so. Yeah.
Yep.
Yeah.
Light's definitely beginning to dim. We have some scudding clouds, but nothing terribly worrisome. And John's here with our table now, so that's fantastic. Thank you.
Okay. No problem.
We're also watching the NASA spacecraft people launching their balloons on the hour every hour. They just launched one a few minutes ago to great applause. And they are launching sensors up into the upper atmosphere to track weather patterns, humidity, winds, wind speeds.
Right. You got that, John, or do you need one of us to come over
Sorry.
and help
Yeah, I
you?
got it.
Okay.
Okay,
Just need a.
perfect. Oops.
Yeah.
All right.
Wonderful, thank you.
Okay. All right. So now we even have a table. Thank you, John. Okay.
I'm fine on the bench.
Yeah, I'm fine on the bench. And
we have an extra chair there. Yeah.
okay. All right. So I think you could see that it's a little bit patchy clouds from looking at these images coming in from the telescope. Um, okay. And again, we apologize for the technical difficulties. We tried this out about an hour before we started going when there were fewer people around and the network worked fine then. But then as the crowd started to gather, there were a little bit more demands on the network. All right, John.
Good.
Okay. All right, so John, you prepared a whole bunch of questions about eclipses for discussion. You want to talk about a few of these things?
Yeah, of course. One of the questions that we got was, one, why do we have to wear solar glasses? I mean, from one of the kids from the high school. Oh yeah, I should preface this by saying all of these questions were provided to us by one of the science teachers from Horizon High School in the El Paso area, who happens to be my sister. So she asked,
They're probably by her or her students?
they're provided by her student.
Yeah,
So
okay.
she asked her students to come up with, or just to give her any questions that they had about the eclipse, and we just collected those, and those are the questions we're going to use, since it's probably what most people would be asking. So one of them, as I said, was, why do we need to wear solar glasses? Or do we have to wear solar glasses during the totality? And so, yes, you should wear solar glasses, especially like up to totality. Technically, you don't have to wear the glasses at totality because the sun's being covered, and the only thing that's emitting the light that you would be able to see is the corona, which isn't strong enough to damage your eyes. From And there's also some really good links, some videos on the YouTube channel about eye safety, and the optometrist or the eye doctor there do go into really good detail on why you should wear the solar lenses and how it damages your eyes if you don't use those solar glasses. Another question that they had asked was, when will the last solar eclipse occur? So
Last
total solar
total
eclipse.
eclipse. Yeah. Okay.
So
Right.
after a certain amount of
Well,
time.
maybe we should remind everybody what happened back in October.
Oh yeah.
Yeah.
So back in October, we had an eclipse as well last year. But that eclipse was the annular eclipse. And the difference between a total eclipse and annular eclipse is that the annular eclipse doesn't completely block the sun. And this has to do with the fact that the moon is at its furthest point from the Earth in its orbit. And so it just can't block the sun geometrically. And so if you look into the future of how the Earth and the Moon orbit's gonna happen, the orbit of the Moon is gonna just keep on expanding. It's going to get further and further away from the Earth. And so eventually there will come to a point where we will never have a total eclipse anymore. It will all be annular eclipses. And this point, I mean, it's a little hand wavy, I guess, because there's a lot of dynamics that come into play. The sun also gonna get enlarged, so that also does cause some differences, and tidal forces between the Earth and the Moon also causes some differences. But most people say around 600 million years is when the last total eclipse will be seen. And after that, we will only have annular eclipses or partial eclipses as the Moon gets further and further away from the Earth. Let's see, what was
so we're really kind of threading the needle to be able to have both annular eclipses and total eclipses at the same time, right? Because the difference between the closest approach of the Moon and the furthest distance of the Moon is really pretty small, right? It's just a couple percent.
Exactly. And we're in the great time where we could see both of these events, because they're both interesting and fun to look at for their own different reasons. Let's see. Oh, a good example of a question that a high schooler asked that I thought was interesting was why don't we have solar eclipses every month? If the lunar cycle, the Moon orbits the Earth every month, why don't we get those every month? And that has to do with the ecliptic plane. So in order for the solar eclipse to happen, the Moon has to get right in front of the sun, but the Moon isn't actually orbiting in a flat plane as the sun and the Earth are. It's not in the same plane. It's sort of tilted about 5 degrees here. That's about 5 degrees off center. And because of that, we have to get, once again, this perfect timing where the Moon approaches in the ecliptic plane, and they both have that like little node where the Moon is right in front of the Earth and right in front, blocking out the sun. But that doesn't happen every month. So that's essentially why that doesn't happen every month. And another thing that we're sort of interested in is why we could only see the Moon in a small fraction, and what fraction of the Earth could actually see the totality, the total eclipse. And the total path is usually around 1% of the Earth's surface. So it's actually pretty hard to land that on where you're at. So Texas is really lucky that we got the path of totality go through a lot of the major cities, actually, or get really close to a lot of the major cities. And so a lot of people could observe it, but that's just coincidental. Most of the Earth is actually not going to be able to see it, or they'll just get partial eclipses in the rest of the US. But yeah, it all comes down to circumstance and getting that perfect timing. And luckily here in Junction, we got that perfect timing, and we're hopefully going to be able to see the totality through the clouds. I mean, there's clouds coming in and out, but it's not too bad so far. Yeah. Oh, okay, there's pretty big clouds coming in.
It may start raining, in which case we may have to shut off here so that we don't get computers soaked with rain. We're gonna see what happens.
Yeah, and it's super unfortunate. Yesterday was so clear, it was so nice.
Okay, so let's Deanna, you want to come over, and I'm going to point to something on the video feed, and maybe you can explain what's going on to folks at home. That just jumped.
Just changed.
I think we just jumped between the black and white color.
Yeah.
But well, we get the same thing. It was a sunspot, right? So
Okay.
yeah. All right.
We have 18 minutes to totality.
Okay, nice.
Okay, so what's going on here?
Oh, right.
Yeah, this is better here.
Yeah, that's much better. We're seeing a sunspot right there. And sunspots are areas on the surface of the sun that are a lot cooler than the rest of the surrounding area. And they are related to magnetic activity on the sun. As we know, the sun has a lot of magnetic activity that's responsible for flares and coronal mass ejections and all of that. And so sunspots come and go. And with more solar activity, of course, they generate, the more sunspots there are, the more solar activity there is, and we're reaching solar maximum sometime this year. And sunspots also have a cycle, but essentially they are areas on the sun's surface that are cooler than the surrounding areas.
All right. Okay. Also, you're here representing Sky and Telescope magazine.
I am indeed.
Maybe you can tell us about what Sky and Telescope magazine is, what kind of articles are in there,
Of course, glad
that
to.
sort of thing.
Sky Telescope has been around since 1941, and it is a magazine dedicated to all lovers of astronomy, everybody who's passionate about astronomy. We primarily cater to the amateur community, and so you can learn about observing, you can learn how to replicate observing certain types of targets that other people have observed, and then they write articles that that are basically like guides to how to replicate their observations. And we also run articles on cutting edge science. And for gearheads, there are plenty of articles on telescope making and other neat gadgets that you can put together to make your observing experience more pleasant. And every month we run a whole selection of articles and columns dedicated to celestial events that occur that month. We're a monthly publication, so we come out every month. And so each month we outline what are the naked eye events that are fun to keep an eye on during the coming month. And then we progressively go to more and more challenging objects. For some things you'll need binoculars, for some you definitely need telescopes, smaller telescopes for certain objects, and then larger telescopes for others. And we also write about the community, the amateur community, and we urge everybody who's interested in astronomy to look up their closest club. There are astronomy clubs in many parts of the country, and if you're interested in astronomy, you can subscribe to Sky and Telescope magazine, which would be awesome. And but once you've subscribed and you've bought your first pair of binoculars or whatever, want to know how to use them, go find a club next to you and close to you, and start enjoying the hobby.
Okay. And so what would be a quick Google link if somebody wanted to find a list of clubs so that they could figure out where there wasn't one near them?
Our website is skyandtelescope.org, all one word. Oh, skyandtelescope, all one word.org. And right at the top, there's a tab that says, I think, clubs and community, but it's very easy, clubs and events. Just click on clubs, and down below, there's another link that says find a club near you.
Okay. And you can kind of search by zip code or something?
Yeah, you can search by zip code,
great.
by map, by whatever. Yeah.
Okay. Great. Because I think sometimes the local clubs are really eager to get new members in, but they don't have advertising budgets. I remember John and I went to Midland, Texas for the annular eclipse back in the fall. And we met a guy who had come down from Lubbock, where Texas Tech is. And he had said he was in a club in Midland because he didn't know there was a club in Lubbock, but there's actually quite a good active club. And he just grew up out of town, didn't know the folks. Yeah.
Exactly. There are lots of clubs out there that like Tom said, don't have the capacity to advertise much. And clubs are very welcoming. They love you to just roll up. Most clubs have a monthly meeting, so check their website for when their meeting is. And in general, this, I can't speak for all clubs, but in general, monthly meetings go so that there's an expert talking on a specific subject, whether science subject, an amateur subject. And then club members get together and go to dark sites for observing. And you can only do that if you're a club member. You can't access the dark sky sites if you're not a club member. So it's really worth joining a club.
Yeah, and so maybe I can talk about something I'm involved with too. So I'm on the board of directors for an organization called the American Association of Variable Star Observers. And, you know, you may see these images from things like the Hubble Space Telescope out there and think there's no way that I, with a small telescope or even with just my eyes, could possibly contribute to science. But it turns out you can, because it actually turns out that there's certain things that amateur astronomers can do that you fundamentally can't do with the big telescopes, like understanding the variability of the brightest stars in the sky. Because you may have noticed if you like take your camera and you point it at a bright light, it kind of saturates. Well, that happens to telescopes too. And so the brightest stars actually saturate the telescopes faster than you can open and close the shutters. And so astronomers rely on amateur astronomers to observe those objects and see how they vary. And you may remember about 5 years ago during the pandemic, there was strong variability from Betelgeuse, which was one of the brightest stars in the sky. And most of the work for that was done by amateur astronomers. And a lot of it actually by people without any equipment at all, just looking up and comparing how bright it was to other stars in the sky and realizing that it had gotten a bit fainter. All right, so there's lots of opportunities to contribute
And
to
that
science.
website is?
aavso.org. Yeah.
Right. And at Sky and Telescope, we also run material on professional amateur collaborations. About once every 2 months, we run a column. We have some information on our website as well, and it's a really fun way to get engaged in research, and see your data, your data used to further our understanding of what's going on in the universe. And you might have done it from your backyard. How cool is that?
Yeah, and if people really contribute a lot of data that makes a project possible, sometimes people without any degrees in a field end up being co-authors on scientific papers. So that's
I'm gonna have to go start getting in videos and things.
yeah. Okay.
Maybe not quite yet.
Okay.
A few minutes. Okay.
Okay.
Sorry. Just
All
so
right.
you know that I'm gonna pop.
Okay. All right. And so now I'm gonna go and take a look at our chat and make sure, see if we have any questions in our chat from people watching at home. Yeah. Okay. All right, so I don't know if anybody at home is trying to put questions for us in the chat, but definitely feel welcome to. Where's the chat on this? Oh no, that's all right.
I have my laptop in here in case it starts raining.
Okay, so all right, John, you think of something else interesting to say while I try to figure out where the chat is, and while we're just
Yeah, absolutely. Let me go ahead and look at my handy papers where
Okay.
I have
yeah, John's got a few more of
Questions.
these questions.
that students were asking.
Yeah.
Let's see. Oh, wow. We went through several of these actually, because this is the first one. Okay, so a really good one that someone had asked is, do people study the eclipse? So is the eclipse worthy for scientific study? And as you had already seen earlier, we have someone from here using the eclipse to study animals, but it's not only biology that they use the eclipse for. We could also use this for astro purposes, such as seeing the corona. I mean, the corona is actually not really easy to see, and it's actually almost impossible to see unless there's an eclipse or something blocking out the sun, so that that great source of light that comes from the sun is blocked out, and we could totally see the corona. You could also, there's some radio experiments that they're doing up in, where were they doing that, in Columbus? Chapel Hill.
Around Cleveland.
Yeah,
Cleveland.
Chapel
Yeah.
Hill.
Yeah.
And where they're trying to see if the solar eclipse blocking out the sun will change some parts of the ionosphere, as in like reducing some of the ionized gas over there, and you'd be able to see some radio effects. But even little things like that have like major impacts that that a lot of people don't really think about. And one of the questions they did ask as well, and the previous people from here from Junction who were talking about their experiments with understanding the behavior of animals, was one of the questions actually that a lot of students from Horizon High School asked, which is if animals perceive the eclipse the same way we do. And like we know, it gets darker, it gets really cold. It's really easy for animals to think that that's part of a nighttime effect, and for them to get really confused. And so it's actually really interesting, and the Sarian Junction is a perfect place for us to be monitoring that, because it's just super green. It's super like nature adjacent. For those of you guys who have been here, it's they could talk about how amazing it looks. And it's actually my first time over here into this campus. And I think it's just a really beautiful patch of land that Texas Tech has, with a lot of interesting people doing interesting stuff. Oh, cool.
Okay.
When will it be at peak? So peak is
It's about
145?
yeah, it's about
Yeah.
140 here.
Yeah.
Yeah.
So peak is about 140. It should last about 3 to 4 minutes at peak.
Yeah.
And yeah. And so how much time is left? I think the entire eclipse is supposed to last until 3, I believe.
Yeah, the entire eclipse is going
Yeah.
to be about 3 hours here.
Yeah.
Yeah. And you can see we're getting pretty close now.
Yeah, yeah, we're getting really close to
Right.
totality.
Oh wait. Oh, sorry. I'm not sharing that.
Oh,
Hold on. Let me go back to sharing the video.
there we go. Yeah. So very, very close actually. It's
Yeah.
about like 80%.
Yeah.
Yeah.
Yeah. And Deanna dropped off because she has to do some work for Sky and Telescope. It's starting to get pretty dark here. It's kind of like what it's like just after sunset. That's about how dark it is here right now.
And
Despite the fact that it's just a little bit afternoon.
and you can totally feel the difference in the temperature. It's
Yeah.
getting noticeably cooler.
Yeah. Okay. And we'll be on for the whole of the eclipse unless it starts raining really hard and we have to go inside. And we'll be happy to take more questions in the live stream chat after the eclipse's totality is ended as well. So we do have some clouds here. So my guess is that from Junction, we're not going to get a great view of the solar corona today. We'll see. We might get lucky and there might be a break in the clouds at just the right time and place. There are a few clear patches up in the sky right now. But we're going to have to kind of play it by ear and see what happens. There's some thick rain clouds gathering on the horizon as well.
Yeah, look.
I'm going to pop out and take a look with my glasses on.
Yeah, and I'll be right here. It was definitely significantly clearer earlier. I was pretty optimistic that we were going to see a nice corona. But that definitely doesn't look like it's going to be the case. I mean, I'm fingers crossed we get really lucky. There's a break in the clouds. But it is definitely getting really dark. It definitely feels like dusk. If I was inside the building, I had no time, like no concept of what time it was. I walked out, I definitely would think that the sun had already set.
Yeah, now what's interesting though is that you get some patches of pretty bright blue sky on the horizon to our left. I'm going to see if I can turn the computer and show that to you all. Okay, so that the sky on our left that I just showed you is a lot bluer than it would be if it were this dark normally, right? And that's because the blue light coming from the sky, that's scattered sunlight. So that's light that's kind of passing around where the moon is and hitting a part of the sky somewhere else and then scattering back into our line of sight. There's not going to be any of that once we get to totality either.
Yeah. And one of the questions that the students, high school students, had asked was how often do solar eclipses happen? And I think they had this question because usually they're presented as something very rare, except we just had two eclipses in a row, like in every year. So they were like, oh, are they every year or how often are there? And they're about what, 18 months is about the time that they usually occur.
Yeah. If you count partial eclipses, some of which are just really the moon just grazing past the sun, I think, about every year and a half.
Yeah. And the thing though is if it's going to happen in a location near you. Of course, if you could just travel to every single one, I mean, you see them a lot more frequently, but not everybody has that opportunity or chance to do that. And so the reason why it's really interesting to have it right here is that we're all really close. I mean, it's in Texas, but not that far from Lubbock. And we just had an annular eclipse, so it just seems like it's a lot more frequent than usual. But if you look up when the next eclipse is going to happen in the US, it's in 2044. So we're going to have to wait another 20 years until the next time we could see a total solar eclipse. So much more frequent than some people think, but not frequent if you're planning on visiting it and looking at it. And it is getting really close to totality. Yeah, that looks nice. So we have about 10 minutes before we reach totality. And it is getting pretty dark. Everybody's trying to see if If you could see it through the cloud, were you able to see it through the clouds with the?
No,
No.
yeah, the clouds are really thick here right
Yeah.
now. The telescope seems to be able to see the sun through the clouds, but we can't.
Yeah,
Yeah.
even in the live stream, it looks like the clouds just completely block the sun out.
Yeah. I think it depends which camera they're taking that off of.
Depending on the frequencies.
Yeah,
Yeah.
it's jumping back and forth between being visible and not. And I know they have a couple of different filters on different telescopes here. And I'm not sure if it's the cloud cover changing or the camera changing right now, but
Oh, okay.
but it could be either of those.
Yeah, it does. It does look definitely super
Yeah.
cloudy.
Yeah, but it is really getting dark out here.
Yeah, it almost makes I mean, some of those clouds are probably maybe storm clouds, but it makes them more stormy looking than I think they would have looked.
Yeah. Okay. So I'm gonna leave that running, and I'm gonna take a look back at our. I'm gonna pull our chat out and take a look back at our chat and see if anybody else has entered anything. But I don't think we've had any new questions since the ones we answered a while ago. Okay.
Oh, yeah. You could see the gradual darkness. It's gradually getting darker and darker.
Yeah. Now, for you looking at us at home, you're probably not noticing how much darker it's getting the same way we are, because of the way these video cameras work. That they make longer and longer exposures to keep things bright. So you're probably noticing us getting grainier and noticing the video getting choppier more than you're noticing how dark it's getting.
Yeah, but here it is getting really dark.
And now oh, sorry. Yeah. Okay.
It is definitely, yeah. People are already like getting very interested in it
Yeah.
because it is getting really, really dark.
Okay. We're going to leave this for you.
Let's see.
Hi, folks. I think now you can really tell how dark it is here.
Yeah, that looks much darker.
Yeah. Oh, John, maybe you can give a little description in Spanish about some of what's going on right now.
Oh, yeah, of course.
Okay.
Bueno, ahorita como la luna se está ocultando del sol, se está oscureciendo bastante. De hecho, ahorita parece como si fuera noche. Hay muchas nubes y por eso no podemos ver el sol. De hecho, si están viendo por el live stream, van a ver que la cámara ahorita que está ahí no tiene nada, no se ve nada, se ve todo oscuro. Y es por las nubes que están ahí en el cielo. Pero sí se ve completamente oscuro. O sea, si fuera una tormenta normal, no se iba a ver así de oscuro. Y todos ahorita andan viendo el cielo, a ver si pueden ver un momento que salga el sol para ver el eclipse. Pero ahorita no se ve nada, está muy nublado. Pero se siente la diferencia en temperatura, se ve la diferencia en el brillo. ¿Ah? Oh, Wait, we're gonna talk about-
We're in totality.
Oh, okay. Okay. Y ahorita estamos en totalidad. La luna ha completamente ocultado el sol. No se ve nada de luz. Bueno, se ve un poquito, haz de cuenta como si fuera noche. De hecho, las luces allá de las lámparas de la calle se están, bueno, ya prendieron porque ya piensan que es de noche, pero no podemos ver nada por las nubes. pero sí, sí se puede sentir, como dije, la diferencia en la temperatura y la diferencia en la oscuridad.
Yeah. Okay. So I think we're starting to come out of totality now. It's hard to tell exactly when if that's happened or when that's happened. And I'm not sure if my clock is synchronized properly. But I think it does actually seem like it's starting to get a little bit brighter here. Yeah. And
Yeah, and
Yeah.
from this side too.
yeah, and it was a little bit less extreme here because of all the clouds, because you get some scattered light that hits the clouds that wasn't supposed to be directed towards us. And so that kind of spread some things out a little bit in time compared to what you would get in a total eclipse in a oh yeah, it's really
Yeah, it is
starting to
really
brighten up
brightening up,
now. Yeah. Yeah.
Now it feels like it's sunrise,
Yeah.
because you could see it, although much faster.
Yeah.
That is
Yeah.
impressive.
Yeah.
The change in brightness is actually very, very impressive.
Yeah. Okay. So
So even though we didn't get to see the corona, it's actually pretty impressive just to see this change in brightness and this change in temperature.
yeah, and I'm gonna take a look and see if there's anything in the chat.
There's a
Oh yeah,
total-
so somebody was saying we couldn't see anything on screen, and I think that was during the period of time when we were showing you the telescope feed, but the sun was almost completely blocked out by the moon. But because of the clouds, we weren't able to see the solar corona, which is this very hot layer of gas on the outside of the sun that you can generally only see with very specialized equipment or during an eclipse. And so unfortunately, we didn't get a chance to see that this time. So I hope we answered that question there about the black screen. Okay, and somebody asked whether total solar eclipse affects plants as well. And that's something that I think we probably want to try to find one of the biologists
Yeah, exactly.
and get an answer on.
I wouldn't know that.
I think the answer is probably a little bit, but it's very hard to measure, right? Because some plants bend, like sunflowers bend towards the sun.
And then, but it's so fast. I don't know
Yeah,
if they're
it's so
able to-
fast that you might not really be able to detect that phenomenon happening, but it probably would if you had good enough measurement equipment.
Yeah.
Yeah. But
Yeah,
I'm not sure about that. That's a really interesting question.
Because the totality is only around like 3 minutes, so you would have to be able to see the plants react in some way that's faster than 3 minutes.
Yeah.
Which plants are not really known to do that.
Okay. All right. So welcome back, Deanna.
Thank you.
Okay. So maybe you could tell us what you were doing over there. Were you taking some movies and pictures for Sky and Telescope?
I was indeed capturing the reaction of the crowd, of all the enthusiastic eclipse watchers.
Yeah.
Unfortunately, I don't know, maybe you already mentioned it, but a cloud kind of obscured totality itself, but that did not deter from the excitement of the darkness, and the young people over here were incredibly enthusiastic, and it is quite an experience.
Yeah, I don't know how good the microphone is here, but we certainly heard some whooping.
Yep, it was quite a bit of whooping. Yep.
Okay.
And it sure got dark.
Yeah.
There's a bit of twilight, of course, and you can see the horizons are not fully dark. But I noticed that a car coming in, it had its headlights on.
Yeah.
So
I even mentioned it in the Spanish when I was doing the Spanish portion, that the street lights turned on.
Oh right.
Yeah, you could see the street lights turn on because it was dark enough to mimic night. So that was something that was pretty impressive.
Yeah. Okay. Let's see if we can get the telescope feed again in them now.
Because now it's clearing up, of course.
Yeah. And there's more sunlight to poke through the clouds.
Yes, that too.
Yeah. Okay. I think we're still not seeing much on that telescope feed. So I think we're gonna hold off on showing that, and we'll just kind of talk to you with the video of us until there's something a little bit more interesting to show there.
Yeah.
Okay.
Yeah, and in parts of during the eclipse, I don't know if you noticed, Tom, that you could see, like, especially over here in this horizon, that the sky was starting to look a little reddish.
Okay.
I don't know if that's normal or that was just coincidental.
I'm not sure about that.
Yeah, I looked over there.
Deanna, you?
Dusky. I mean, it could be also dust, but it was definitely very blue on this side. This side over here.
Yeah, this side was very blue. Yeah.
Yes.
Yeah, and when I was looking over there, it looked a little red. but it could also just be
that was, yeah, that was the horizon.
Yeah, yeah.
Yeah, where, yeah.
yeah. So I found that
Yeah.
interesting. Yeah. But yeah, it's definitely a lot brighter now. Like even my eyes,
Yes.
Yeah,
like,
yeah.
got
And yet
took a
we're
while to
only
get accustomed.
a few minutes past totality.
yeah, yeah,
And it
significantly
shows,
bright. Yeah.
it shows how little of the sun you need to create
Oh,
brightness, right?
Yeah.
Yeah,
Yeah, I mean, even like, on a regular day after sunset, it's still bright from just a little bit of sunlight scattering over the horizon for,
mhm.
usually half an hour or so. All right, we've got a Texas Tech mariachi band playing in the background over there.
Yeah.
Okay, and
Celebrating the totality.
I'm gonna see if we can patch into NASA's live stream of the eclipse, because I think some places further to the north and east are gonna have better weather today, and NASA has some telescopes set up several places along the line of sight, and we may be able to catch one of them.
Oh, that
Okay.
was in Dallas.
Okay,
Yeah, you can't. Oh, I mean, barely, I guess.
yeah, I think it's a little bit clearer in Dallas than here. Actually, the other thing that NASA's doing. Oh yeah, we weren't showing that to the people in Dallas also. Is it the okay. Zoom, share screen. Okay. All right. So it looks like it's just about to go into totality in Dallas. We're about 200 miles from Dallas. And so the eclipse path is gradually moving to the north and east.
Hmm.
All right. And not
Oh.
sure what they're doing in there.
That could be like small amounts of light going to the clouds. Like, no. Yeah, it looks pretty dark.
Yeah.
I mean, the great majority of Texas was going to be under cloud cover.
Yeah. Yeah.
Oh, wow. Is that? Oh,
That looks like we may be seeing some solar coronal
Yeah.
emission in that
Yeah.
image from Dallas. So it looks like it's clear in Dallas.
yeah, I think it cleared up there.
Yeah. Okay. All right. So who wants to explain the solar corona to our listeners at home? Okay. So the solar corona is a region on the very top layers of the sun that's at a temperature of about 1,000,000 degrees Celsius. That I don't know if they that looks like they might have had a technical glitch there.
yeah, because I saw the stripes.
Yeah. And that's okay. Now we're going to
Oh.
Arkansas, a little further up the path. And you're going to kind of see if NASA keeps going from telescope to telescope, you're going to keep seeing the same things happening again and again. Okay, and here's Dallas again. All right, so that solar corona is not, people don't fully understand the solar corona. Like they don't understand nearly as well as the surface and the interior of the sun. But the idea is that there's some loops of magnetic fields, and if you know how you have a north pole and a south pole on a magnet, every once in a while these loops kind of cancel each other out. Like a north pole gets put next to a south pole, cancel out the magnetic field, and that releases a whole bunch of energy that can cause electrons to move very quickly if they're in the region where that happens. And that's the general idea about what people think about how the solar corona gets heated. And some of that material then keeps flying out towards us, and it makes the solar wind. When there's a really extreme solar wind event that comes near the Earth, it can sometimes do some damage to some satellites. Or there was one event in the 1800s, the Carrington event, that did a lot more damage to electronics, even as primitive as they were at the time. And that's also what causes the aurorae, when those very fast charged particles come near the magnetic fields of the Earth.
Yeah, and this really brings me to one of the questions that the high school students had, and I'll ask it to you. But they were wondering if during a solar eclipse, is there more likely to have like coronal mass ejections? Is basically what they were worried about, and it affecting technology. Essentially, I'm pretty sure they saw it on TikTok that like during an eclipse, you should unplug electronics and be careful with electronics. I mean, of course, that's not true, but but that was a question they did ask too. And I actually did get some people asking me from Mexico as well about whether that was necessarily true. But yeah, no, that's not true.
No, the movement of the moon in front of the sun and that creates the eclipse, and then the coronal mass ejections that happens at the sun are completely unrelated. But what can happen is that if you witness a coronal mass ejection during a total eclipse, you can actually see it, even us with our eclipse glasses would be able to see it. They would look quite spectacular, but they're completely unrelated. Yes.
Okay. And I'm gonna see if I can get another computer going now, and so that we can keep an eye on the chat from you folks at the same time that we show you something a little bit more interesting than us showing you the time lagged version of the video that you're looking at. Okay, so okay, turn the sound off on that one. All right. Yeah. All right. So I think we haven't had any new comments from folks watching at home.
Excuse me. You know who's in charge of selling those t-shirts?
Yeah. Okay. So we have somebody coming by asking us about t-shirts that we have for sale here. If you find Robert Stubblefield or Karen Lopez, give them $20. You can take one. I think the folks over there may know more than I do about that also. Yeah.
Those are them.
Yeah.
So if I leave $20 with you, can I take one?
Yeah, I'll get the money to them if you do that. Yeah. Okay.
I'm gonna take a extra large.
Okay. Okay. Thank you.
Thank you, sir.
Okay. All right. So yeah, so now we moved up to Arkansas. And you could see they're getting pretty close to going into totality there. And so this is going to progressively happen at later and later times as you go to the north and east. And NASA set up some telescopes all along the path. All right. So one other thing is that even though we had a cloudy day here today, there's probably actually going to be some good video of the eclipse here in Junction that NASA has collected because there's some student groups that NASA has sponsored to do balloon launches for scientific ballooning from several sites along the path of the eclipse. And one of them is setting up cameras that are that were observing the eclipse. And so hopefully their balloon launch worked. I think they probably won't have the video available until a little bit later. Yeah, there's a few other ones that are doing some atmospheric balloon launches.
Yeah, that looked pretty impressive. I know the Exploratorium had one of them launch it right in front of them, but they've been launching every hour on the hour for the last, I don't know how many days.
It's gonna be 30 hours in total
30 hours in total.
from the first launch to the last.
Yeah, and they were doing that all night as well. When I went out at night, I could see them still launching. They still had all their lights and stuff. So pretty cool stuff that they're doing.
Yeah. Okay. Actually, Diana, there's something else I wanted to ask you
Sure.
about. Suppose somebody is watching this and they've suddenly gotten really excited about astronomy and now they want to buy a telescope. What kinds of things should they look for, and how should they be able to figure out what's going to work for them?
There's an old adage at Sky and Telescope, which is the best telescope is the one that you're actually going to use. So you mustn't start off with anything too complicated, anything too gadgety, anything too complicated. And I would say that probably one of the best things to do is get the simplest telescope you could find and start to find your way around the sky, just visually by star hopping. You find a bright object and that leads you to a fainter object and so on. And these can be very simple refractors, just a tube with two lenses at either end, and they're incredibly lightweight, and you can push them around the sky quite easily. And then after you've learned your way around the sky, then you can start looking for some more serious instrumentation. But at skyandtelescope.org, for example, we do have a guide on what to look for in a telescope. And if you subscribe to the magazine, every month we have articles on telescope buying, and well, maybe not every month on telescope buying, but we do give advice on what's good in a telescope or what isn't. But I would not recommend anybody who's interested in getting started in astronomy to go straight away for like the 12-inch with a lot of electronics and so on, because the heavier and the more unwieldy a telescope is, the less likely you're going to drag it out and actually use it. And in fact, most people have a pair of binoculars in the house. Just take them out and start scanning the sky with that. Look, we're seeing the Bailey's beads.
Oh yeah. Okay. All right. You want to explain what the Bailey's beads are?
Bailey's beads are actually sunlight coming through the valleys and the dips in the moon's surface. The moon's surface is not smooth. It has craters and now we've lost the feed. Anyway, it has craters and valleys and so on. And so Bailey's beads are sunlight coming through the depressions on the moon's surface. There we go. There we see it again. Yeah.
Okay. All right. And John, this is a really exciting one. Maybe you can explain this in Spanish also.
Sí, bueno, ahorita lo que podemos ver son unos puntitos que se ven por ahí que se llaman las perlas de Bailey. Y eso se puede notar, se puede ver porque la luna no está parejo, no está en plano, no, tiene valles, tiene montañas, y cuando la luz pasa entre esos valles y montañas hacen que se vean como unas esferas de luz que le decimos las perlas de Bailey. De hecho, aquí se pueden ver muy perfectamente los círculos blancos, y es por la luz que está pasando por la superficie de la luna, donde se está pasando por las valles, montañas y creando ese efecto. Okay.
Yeah, thank you, John. All right, and this is really, if I understand right, if I remember right, this was really the first evidence we had that the moon wasn't a perfect sphere, right?
Exactly.
Yeah.
Yes.
Yeah.
And that there were craters and mountains and valleys, and that it had a rugged surface.
Yeah. All right, we have a question in the YouTube chat. Have scientists planned any experiments or specific observations for this eclipse?
Yeah.
So I think we've talked about a couple of them already. You want to do this one, John?
Well, we talked about the Chapel Hill one.
Or
right?
that was in Cleveland.
That was in
yeah,
Cleveland. Never mind.
Yeah.
Yeah. So we talked about the Cleveland
Yeah,
one.
maybe I can explain that one a little bit more afterward.
Yeah.
The list, but yeah.
Yeah, there was that one. Of course, there's the NASA one that they're doing here with the balloons. I don't know if there's any other specific experiments that other than the ones, the wildlife ones. They're doing the ozone measurements is also with NASA, with balloons. Is there any other ones that you know of?
They're doing some citizen science.
Okay.
They're doing some citizen science experiments, and I think they tested it, or they did it, one experiment the first time in 2017. And that is NASA, in association with other organizations, have contacted or have requested that people along the path of totality take photos during totality of the corona. And then what they've done is they've stitched all those images together, and like this, they get a 90-minute long movie of the corona. They call it, like, they can see the dynamic corona, the corona sort of evolving in time over 90 minutes. And so they I don't remember how many cameras, how many photographers they had along the path, but enough to be able to put all these together to come up with a continuous sort of movie that shows how the corona evolves. Because the thing is, during totality, like today, totality was about 3 minutes, right? And so if you have just one observer in one spot, you only get 3 minutes of coronal observation, and it doesn't tell you very much. But if you have people all along the path, you have a real timeline of about 90 minutes of a continuous coronal observation.
Yeah, and maybe I can tell you too. I don't know if somebody is probably doing this experiment again today, but one of the most famous scientific experiments that was ever done during a solar eclipse was something called the Eddington experiment. And this is after Einstein proposed the general theory of relativity. This suggested that light didn't travel in straight paths when it moved near a massive object. And this was sort of a ridiculous notion to people in the early 1900s when it was first proposed. And so people realized, though, that the only massive object close enough to us at the time that people understood was the sun. And the problem is, and they realized that you could get a measurable shift in the positions of stars near the sun. And the problem is in daytime, you can't measure the positions of stars, right? And at nighttime, nothing is near the sun.
No sun.
Yeah. So what they realized was that they could wait until the next solar eclipse and they could set up some telescopes and see if the separations between stars near the sun were a little bit different than they usually are. And they were successfully able to do that. And that, yeah.
And that was a professional expedition led by Sir Arthur Eddington, right? You
Yeah.
said that, right?
Yeah.
And that was to West Africa during the 1919 eclipse, as you said.
Mhm.
And there, during 2017, a group of people did recreate that, a project led by Don Bruns. And now they're redoing it, certainly for this one. And they have they've set up several locations between Mexico, Texas. I'm not sure if anywhere outside of these two locations. And a group of people have gotten together with schools and gotten students out, and they all have telescopes set up, and they're redoing it now as well. So keep your eyes on various astronomy news outlets and so on. You might read up on the results in a couple of months' time.
All right, and now maybe I can talk a little bit about the experiment John mentioned. And by the way, we're coming up on Carbondale, Illinois. Carbondale, Illinois has the distinction of being a place that got the 2017 total eclipse and is getting a total eclipse now again. And it also happens to be the home location of a prominent popularizer of astronomy, Pamela Gay, who's done a lot of work with helping get people prepared for both of these eclipses. So she was sort of deservingly lucky, I guess, to happen to be in the path of both of these. Okay, so John was talking about an experiment using radio telescopes that people are doing today up around Cleveland. And this is mostly being done by a guy named Tim Dolch at Hillsdale College, who's working with a bunch of undergraduate students there. And one of the things that's interesting is we have a region of the atmosphere called the ionosphere, and this is made up of ionized gas. And so if you've ever noticed, for example, when you drive at night, you can listen to radio stations coming from all the way across the United States. If it's a high power radio station, that's because low frequency radio waves bounce off of the ionosphere. So higher frequency ones like FM radio, those will go through the ionosphere. Now it turns out that if you change the ionosphere is ionized by the corona of the sun, this million degree region on the outside of the sun. And so during an eclipse, even a partial eclipse and even on a cloudy day, the ionosphere gets blocked by the moon. And that, the solar corona gets blocked by the moon. And that should lead to changes in the ionosphere that should make the ionosphere a little bit weaker and maybe let a little bit more low frequency radio emission from space come through and reach the Earth. And what they're trying to do is measure that. And at the same time, they might also measure solar flares, which emit in that band, right? So they can carefully watch what's going on and see how the whole sky changes in radio brightness during a solar eclipse. And that can tell you something about how fast the ionosphere responds to changes in the amount of radiation hitting it, right? Because this is a much more rapid effect than when you go from day to night, right? But day to night also has changes in the ionosphere, right? So that's the kind of thing that you can do with low frequency radio telescopes. And they were up around Hillsdale College in Michigan. Closest place to totality for them was Cleveland. It looks like it might actually be a nice day in Cleveland, but usually it's not this time of year. And Tim's a radio astronomer by training anyway. So I think he thought that was a good opportunity to do some science up there. You've been listening in. Do you have some? You want to pay for a t-shirt? Okay, I'll hold the money and then I'll find them. Sorry? Yeah. If you have any questions that you want to ask us, we're happy to answer them.
Connection between the idea of the music of the spheres and actual music?
No, that's an interesting question. Okay, are you from one of the bands?
So I'm a history professor, but
oh, okay,
it was I thought it was really cool.
Okay,
they did because it's ancient great idea.
Can you come over here? If you can tell us about that, that would be great.
Sure.
Okay, and can you introduce yourself?
Okay, so I'm Dr. Virginia Wheelton. I am.
See if you want.
Oh, okay. Come around with me. Nice. So I'm Dr. Virginia Wheelton. I am an assistant professor of history up at Texas Tech, and I focus on music history. So I have a relationship with this mariachi group, and this was a pretty historic event in Texas for music. But also, I love the way that this event brought together some different ideas of. So with the Greeks, they had this idea that there were three different types of music. Music that basically, not quite, but basically as we think about it, which is like music you can hear. Then there's the music that keeps the human body together, and then there's the music of the spheres. And I think that a lot of times now we tend to think of like music and science as very different things. And I love the way that today we sort of celebrated bringing back together these two things that we often put in different categories. And so thank you for making that possible.
Okay, yeah. So the person who really deserves the thanks for everything going so well today is Shirley Madison, who got this. She was an acting or interim vice provost for outreach and engagement, ending a few months ago. But she did all the groundwork for this, and she did a fantastic job. And Rod Williams, who's our new permanent person in that role, did a good job of picking things up and keeping them going smoothly. But I think Shirley is the one who really deserves a big round of applause for everything that happened today.
Well,
Yeah.
Really,
Yeah,
thank you
and
all.
it was really interesting what you had to say. One interesting thing is there's astronomy for a long time was mostly focused on making the deepest images, but now we've kind of, for a lot of things, we've kind of gone as deep as we can go, and people are making repeated images of the sky again. And so time variable astronomy is a bigger deal than it used to be.
Yeah.
And a lot of people are doing sonification now as a way to
Really?
help lay people understand, but also maybe help blind people understand what we're doing.
Oh, that's great. And also I know composers who use astronomical data to create compositions. So
yeah.
it's and that's one of the great things about Texas Tech is you can bring all this together.
Yeah. Yeah, one of the things I really like about Texas Tech is the boundaries between departments are a lot looser than a lot of other places. Yeah, yeah, and very nice to meet you.
Nice meeting you. And here's money for 2 t-shirts.
2 t-shirts. Okay, I'm gonna have to find the people who are really collecting the money. In a bit, but, I'm on video taking this, so I'll
So
definitely have to turn it in.
there's no way you could
Yeah.
you didn't get it.
Yeah. Okay. All right, thank you.
Any effect of what the eclipses for that region were done? Oh, I'm assuming if we met any eclipses for the radio stuff.
Somebody put a question in that said any effect of eclipse for that region where it done, and we're not quite sure we understand the question. If you could try to rewrite it with a little bit more detail, that would help us answer it. Thank you. Okay. So I'm trying to think, we had a few other things planned to talk about, but now
But yeah, no,
Yeah.
right, spacing out from, I guess all the shifting around.
yeah.
Yeah.
Okay, and it's
We were gonna talk to someone else right after the eclipse.
Oh,
the
yeah.
NASA
yeah,
balloon-
yeah. The NASA balloon people. We're gonna see if we can get some of the NASA balloon people to come over and talk to us in a bit.
wanna go and some.
Yeah, see if anyone's not too busy over there. Yeah. Okay. All right, and now I'm trying to figure out where NASA's feed is coming from. Carbondale, Illinois now. And you could see rapidly moving through the middle of the country, gone from Arkansas to Illinois, and we're seeing pretty much the same thing we saw before. Oh wow, now it looks like Carbondale is emerging from the, is it emerging from there? Yeah, Carbondale is emerging from the eclipse, and you can see they kind of had to
that was the diamond ring.
change a what ring?
That was the diamond ring, that
Yeah.
bright,
Yeah,
yeah.
and you can see now they've changed the contrast on their
Mm-hmm.
camera. See if I can move this back so we can get both of us in the shot. Yeah. Okay. All right, and I'm not sure where is next along their path.
Cooler?
Yes,
All right, and in the meantime, John Morales is looking to see if he can get some of the people from the NASA balloon experiment to come over and talk to us about what they're doing. And this is a really exciting project. They've got a whole bunch of different teams of undergraduate students doing scientific ballooning funded by NASA. Um, and okay, now we're coming up on Indianapolis. And so scientific ballooning is really actually quite important to NASA. We usually hear about rocket flights and satellites, but balloons are a much lower cost way that they can test out scientific hardware before they spend the money to put it onto a satellite. So a satellite mission usually costs a couple $100 million or more. These NASA balloons that they're doing here, they told us it was about $250 per balloon. And they get their parts back also. So they can relaunch them for lower cost for the second run. Okay. All right, looks like Indianapolis might have some clouds the way that looks. Okay. All right, so keeping an eye on the chat also. Okay.
No, have a stream. Come on.
Yeah, I'm not sure what we're seeing here on this Indianapolis one.
That's a diamond ring.
Oh, wow. Okay. Okay, so
Developing it. Yeah.
okay. Oh, I see. So it was so bright that
Yeah,
it was,
it's still right.
okay,
Now it's
yeah,
now it's coming to totality.
yeah. Okay. Okay. All right, and once again, you can see the brilliant solar corona.
Yep.
Okay, so kind of a interesting thing is the sun, and I'm pretty sure it was in the corona, is where helium, the chemical element, was first discovered.
You know, I think you're right, Tom.
Yeah.
I think I've heard that too. Yeah.
Yeah, I know it was from the sun, and that's why it's called helium.
Yes, from
Uh,
Helios.
Yeah, and
the
I
Greek
think it
god
was
of the
during
sun.
an eclipse. Oh, you have
Yes.
somebody from
Oh,
NASA
excellent.
ballooning.
I will wait.
Okay. So if we could get you in the camera, and if you could introduce yourself and say what you're doing.
Yeah, awesome. Hi, I'm Angela Desjardins. I'm what's called the principal investigator, which means the lead of the nationwide eclipse ballooning project. So we've been here at Texas Tech at Junction with a few different teams, some who are what we call atmospheric science teams and some which we call engineering teams. The atmospheric science teams actually launch little sensors called radiosondes, which are the same thing that National Weather Service uses twice a day, every day. And that gives us our weather predictions. And they fly one of those every hour for 30 hours, 24 hours before the eclipse and 6 hours after. But then we also have our engineering teams, and they fly bigger balloons with student-built payloads. And those actually have all different kinds of experiments, including live stream cameras. And they show the view from the edge of space, as we like to call it, where you can see the curvature of the Earth and the blackness of space. It's pretty cool. So yeah, we've been working toward this for a long time. And super excited that it's Eclipse Day and the eclipse is still traveling across the country, heading toward the north. Yes, it's very exciting.
Okay, so did you all get some good video of the total part of the eclipse here by being above the clouds?
That's right. They would have gotten some amazing video from above the clouds. And, so there's some live stream versions, but they also store data on the balloon as well. And those are like higher resolution videos that once they go pick up all of the payloads, they'll have all that amazing footage.
Okay, so
and lots of data too.
okay. Oh, so they have to actually go and pick up the balloon where it lands to get access to that.
Yep.
Okay.
Yeah. The engineering teams do. The atmospheric science teams, the little weather sensor, they don't recover that
Okay.
because they have to have line of sight to be able to see where it is. So
Okay.
they lose before it hits the ground. They lose the connection, so they don't know exactly where that's
Okay.
at.
So it's in the middle of someone's ranch somewhere, and they'll pick it up and wonder.
They also have stickers on them that say this is part of a NASA sponsored project, and yeah, and then that gives them the information about who they can contact if they want to, but usually we don't have them send it back. It's a cool souvenir.
So how many total students across the country were involved in this program this year?
Yeah, so we have about 800 students who've been involved in the project this time. So they've had from many different institutions. We have about 75 different institutions that are part of the project. 30% of which are from minority serving institutions, and 15% from community colleges.
Okay.
We're really trying to make sure that we get some of the institutions with less resources involved so that they can continue to do this. So everyone will keep all of their equipment and everything and be able to keep doing ballooning for a long time into the future.
Okay, and of course, for those of you from Texas Tech watching, of course, we're a minority serving institution as well.
Yeah.
Yeah, we should get involved the next time you all do
Yeah,
this. Yeah.
totally. 2045.
Yep. Now, is some of the stuff that would be interesting to do in a partial eclipse?
Yeah, I mean, there's always really interesting things. You know, we did this for the annular eclipse as well. And one of our big science questions was, do some of the atmospheric effects that we see during a total eclipse, do those also happen during an annular eclipse where the sun isn't completely blocked? But a lot of it is. So like it still got cool, you know, not as dark and cool as it got here. But yeah, so there's definitely still some interesting things to do there. And there's lots of really interesting science to do with balloons, you know, outside of eclipses.
Yeah, I kind of mentioned that before, but like a lot of payloads can be tested on a balloon before you spend
Yep,
$200 million to
testing.
launch it into
Yeah,
space.
there's lots of atmospheric science
Yeah.
testing, really interesting things with radiation, from like cosmic radiation and things like that, radiation from the sun.
Yeah.
Yeah, all different kinds of really cool things that can
Yeah.
be done.
Yeah. I mean, I mostly do X-ray astronomy myself, and a lot
Oh
of
yeah,
harder X-ray things were prototyped on balloons. And
yeah, and like on big balloons,
Yeah.
especially too.
yeah, and sometimes the ones they sent to Antarctica for a few
Yeah,
months.
that's
Yeah.
right. Antarctica or Norway.
Yeah.
Mhm.
Yeah. Okay.
Yeah.
Anything else that you want people to know?
I don't think so. Mostly just that it's a really great opportunity for students to be able to get their hands on a project that's really like a NASA mission. So it's a really great
Yeah.
career making opportunity. So anytime students can get involved in those kinds of things, hands-on things outside of class, I highly recommend it.
Okay. All right. Thank you very much.
Yeah, definitely.
And this really is a great project.
Yeah, it's so fun. I love it. Yeah.
It got dark.
Oh, yeah, well, you can see in here, you can see the office lights
Yeah. Actually, Shirley, do you want to pop on our live stream for a bit?
Yes, so.
Okay. I'd like to make sure that people see so this is Shirley Madison here.
Hi.
And maybe you can introduce yourself, but Shirley is really the person who did the most to get this event to be the success it's been.
Well, you're way too generous and way too kind, because really it's Robert and Kieran
Okay.
probably really put things together. So at the point in time where we were working, I was the interim vice provost for outreach and engagement. Really felt like this was an opportunity to really showcase for a large majority of this part of the state exactly what we happen to have here at Texas Tech at Junction. It's kind of a hidden gem.
Mhm.
You know, I mean, really, it's a gorgeous setting, but it's really a research station. And so to bring in astronomy, any of the things that are happening there along, because we do all the mammals pretty much, deer, you know, armadillos, all the things that they are, but just trying to excite the next group of whatever type of scientists are going to be. They could be citizen scientists for all I know, but just really trying to excite the group and get the next generation up and going, because we know that we have to look towards the future, and the future for this, for another solar eclipse in the United States, if you're not counting Alaska, which is going to be in 2033, is 2044, and that's going to be in not a very populated area.
Yeah,
where
just a little sliver of
different-
Montana,
yeah,
maybe
yeah.
a little in North Dakota.
Yeah, whereas this is going through major metroplex areas in Texas and then continuing on.
Yeah, Indianapolis,
But so
Cleveland,
given,
Buffalo.
right, yeah, just a little south of Detroit, et cetera, and then continuing on into the Northeast. And so you can't really pass up an opportunity like this to go ahead and excite the next generation.
Yeah.
And so that was the cool thing. And then as you know, this one, I actually had the annular eclipse in October. Had a chance to go ahead and work with our Costa Rica campus on Texas Tech, help them out a little bit with some of their ideas. And, you know, I think it's just a really great idea to go ahead and showcase the facility, but also give people a really interesting event that I have a feeling they're gonna be talking around the table for a while, you know, and saying, hey, where were you? Do you remember the eclipse? You know, what was the weather like? What did you experience? You know, just a lot of things that can go happen with that. So,
Yeah. Yeah. Well, thank you very much, Shirley.
thanks.
Okay, I'm going to take a look and see if we have any more questions in our chat, but I think we don't right now.
Beautiful. Well, thank you for coming. Appreciate you being here.
It was lovely to be here. Yeah, it was really nice. Yeah, it was great. The atmosphere was fantastic.
Well, and having kids here.
Yeah.
Wide variety.
Yeah.
Middle school to college students.
Yeah.
Really makes a difference.
Oh, did you get a Chanel to talk?
I didn't. Yeah, can you see if he's busy now? Yeah.
Based
Yeah,
here,
so-
are you?
No, I'm at the
You're up
tech-
at Lubbock?
yeah.
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 Yeah. Though I get down here, well, I got down here quite frequently last year. And part of that was to just really showcase the facilities more than anything else.
Yeah. So how big is this campus?
This campus is just over 400 acres.
Okay. Yeah. So for people listening at home,
Yeah.
yeah, it's about 400 acres here,
Yeah.
which is larger than a lot of major universities campuses if they're in the middle of a city.
And
Um,
we actually are, the Llano River runs through us for at least a mile. So
Okay.
that, you know, that's kind of an important part because we do take care of the aquashed, you know, we check the health of the river, et cetera. So that's an important aspect for us too. Yeah, really get Robert over here.
Yeah. Yeah. That would be good. Yeah. Yeah.
Yeah, he's not over there.
Okay.
I don't know if it's like back there, but okay, then I might take a look.
Yeah, you don't want to mess them up over there. Yeah. Okay. So we're gonna see if a little bit later, before we totally disappear here, if we can get Chanel Varani. Who's yeah. Well, it was still something. Yeah.
Well, I love
Yeah.
it, but you know.
Okay. All right. And I think we're gonna zoom out. I think the clouds have thinned a bit here, and we may be able to. Yeah, we're gonna be able to show you what we're seeing here in Junction again. And so I'm going to switch back to that feed. And we're going to see if we can get Chanel Varani, who's helping with the Astronomical Society of the Pacific, which has a Eclipse Ambassadors program that's done a lot for this eclipse. We're going to see if we could talk to him in a bit. But in the meantime, we're going to show you what we're seeing here in Junction again as the sun starts to, or as the moon starts to pull its way across the sun and go back to full daylight. So what we've got on the screen right now is what we're seeing. And I'm going to take a little break and look through the eclipse glasses.
Thanks.
That's a good plan. That's what I want to do.
All right, so I'm going to do a little eyewear modeling for you all, folks. I can no longer see the screen because these are pretty solid. But this is a set of eclipse glasses that I got from the South Plains Astronomy Club. So if you're in Lubbock and you're interested in getting into an amateur astronomy club, South Plains Astronomy Club is the one to get into. If you Google that, you'll be able to find it pretty easily. They meet in St. John's Methodist Church across the street from campus for their main meetings, and they've got a couple of dark sky sites that they go out to. They also organize some star parties in town from time to time. Okay. Do you have some time, Sinead? Yeah. Okay. All right. So let's see if we can.
Get my phone out of my pocket.
Yeah. Okay. All right. So maybe you can introduce yourself and tell everyone what you've been doing, and maybe tell them what ASP is all about. Also,
Love to.
because I think even a lot of professional astronomers know that you have a journal that you publish, but they don't realize half of what else you all
Right.
do.
So my name is Chanel Bereni. I'm with the Astronomical Society of the Pacific. The Astronomical Society of the Pacific was founded in 1889 in San Francisco, actually because there was a solar eclipse that was passing over Northern California at the time, and they wanted to generate excitement, enthusiasm, and science engagement. And so since then, that's exactly what the
Oh, no, you're good.
We got a question in the chat, but we'll take it after we're done.
Gotcha.
talking.
Yeah. So clearly I have very limited experience doing this because I'm confounded by technology. But so we have a program called the Eclipse Ambassadors Program. So we were here today in Junction with 2 ASP staff, myself and Tony Smith, and 5 of our Eclipse Ambassadors. The Eclipse Ambassadors, they number 700. They're around the country, including Guam, Puerto Rico, and DC. And for the last year and a half, it's been a grassroots effort to engage local communities in the science of eclipses, the wonder and awe of eclipses, how our ancestors would have interpreted them, some fearful, of course, and then some would have been awestruck like we were today. And so we were here doing science engagement with a group from Talkington, a middle school group, and then an Upper Brown high school group. And it was just surreal.
All right. What else does ASP do?
Oh, right.
Yeah.
So the ASP more broadly is engaged in science communication, science education, and science literacy. Really, it's to share the wonder and awe of astronomy with the general public. We have a magazine. It's called Mercury Magazine. Relaunched. It's $20, so it's affordable even for high school students and undergrad. And it looks at the nexus, at the intersection between science and culture, science and art, and sharing some of that cultural astronomy stories. There are fantastic magazines that do the hardcore science, like Sky and Telescope. And so we have to find our own niche with Mercury. And so there's also the publications of the Astronomical Society of the Pacific that's geared towards more research astronomers. Large publications that have a lot of data, a lot of surveys, that look at a lot of instrumentation. Those are perfect places to publish. A lot of undergraduates now are publishing with the PASP because it's a great way for advisors to get their students work published with low page charges or very little. And so for undergraduates that are, of course, want to get papers published before they apply to grad school, it's a great model to get work published.
Okay, and you all operate off endowments or grants or donations or
a little bit of both.
bits?
Yeah. We have a small endowment, and of course, it had to be used during COVID to support a lot of the staff. So, so that took a hit, but we are very grant dependent. So we have two big proposals actually. So Eclipse Ambassadors is a NASA funded project. And then we had a second project, which was funded by the NSF called Eclipse Stars. And Eclipse Stars targeted high school teachers, graduate students, and early career astronomy PhDs that want to do science communication, science engagement, best practices in how to reach underserved communities and to talk about science that's inclusive to everyone.
Okay, and it was really awesome seeing your group of students going around talking to students mostly from Lubbock high schools and middle schools today.
We had a blast, and the students from Talkington had a blast.
Yeah.
And just so you viewers know, Tony and I went to the same school.
You meant Tom, right?
What did I say?
Call me Tony. You probably think of Tony Smith and then
This is what happens when you're doing this. Yeah. I apologize. I meant Tom.
yeah,
Tony's my
yeah,
colleague.
Yeah.
Tom is my colleague too.
Yeah.
I'm leaving now.
Yeah.
You think it's kind of
Okay.
Okay.
All right. Thank you, Chanel. Okay. So
Oh, is this?
wait, is this your phone? Okay. Yeah, so they had a lot of nice scientific demos. I think probably many of them are accessible from their website. And they have a lot of things that you could put together with like $1 worth of equipment if you follow the patterns. All right, so now we're seeing the eclipse starting to end. And we get another nice sunspot image here. Okay.
We did get a question.
Oh yeah, okay,
Yeah.
yes.
So someone was interested in what the eclipse would look like if a person was on the moon. So on the visible edge or in the dark area. I mean, if you're in the dark area, that side would now be facing the sun, correct?
Okay,
I don't know if they
okay.
meant the dark areas in like the dark side of the moon, which would now be facing the sun.
Yeah, okay. So yeah, let's just explain so just explain how you want to explain it.
Oh,
Yeah.
I was just gonna
Yeah.
if the dark side means the dark area means the dark side of the moon, that's always facing away from the Earth.
Yeah, people call it the dark side of the moon, but they should really call it the back side of the moon.
Yeah,
Or the far side of the moon.
Yeah. And that side during an eclipse would be lit up because the sun would be directly in front of it. So that's what a person would experience on that side. On the edge, I don't know if would there be any difference between being on the edge during a solar eclipse or during any other time? I mean, unless it's
I don't think so.
I don't think so
Yeah.
either.
But
Uh,
if they were on
If they were on the light side.
The near side.
Yeah, the near
the
side.
near side, which would be dark during a solar eclipse,
Yeah,
right? The
exactly,
near
yeah.
side that is usually the lit side,
Yeah.
Mhm.
but during a solar eclipse is the dark side. So if you mean, if the questioner means the dark side, then they'd be facing Earth
Yeah,
and they'd see a fully illuminated Earth,
yeah.
except for the shadow of the moon crossing the surface of the
Oh,
Earth,
yeah.
right?
Yeah, that would probably be fascinating. if
That
you could be on
would.
the moon.
And
Eclipse.
but the astronauts on the International Space Station can see that.
But they see
Oh, wow.
They
Yeah.
see the shadow of the moon crossing the Earth, and you can Google that, International Space Station, moon, shadow, Earth, and it should pull up some images. There are a couple floating around showing
Oh,
what,
wow, that is
yeah, it's
really
pretty cool.
So were they in the right place this time? Because the space station takes about an hour and a
90
half.
minutes
Yeah.
I
orbit
have
the
no
Earth. Yeah.
idea. I have no
Um,
idea where they were in their orbit.
Yeah. They could probably control the space station well enough that
they could
if
get
they
into
really
the-
wanted to, they could.
Really?
I think so,
Cool.
because they can make little orbit adjustments
Little
and
adjustments,
yeah. If you planned it long in advance, you could change the orbit by 30 seconds and
But they might catch some of it because the whole eclipse, like from touchdown to when it leaves.
yeah,
I can't remember how long this one is.
Yeah.
It about 90 minutes?
I think it probably is. Yeah.
So they
Yeah.
could probably catch either the very start or the very end if they're over. They must catch some of it because if the orbit of the ISS is about 90 minutes, right?
Yeah.
They should be able to catch some of it
Yeah.
at least. Yeah.
Yeah. Yeah. They could probably
Or
set it up so
depending-
they catch a lot.
Yeah.
Yeah. Yeah. Yeah.
That's
That's
it.
really a nice question. Thank you.
Yeah,
active
made
learner.
us all
Yeah.
made us all think.
Yeah.
Yeah, that was actually a really cool.
Yeah.
Interesting question.
Okay.
Yeah, it
so-
looks like we're nicely finishing that eclipse.
Yeah. Yeah. We
Pretty
still got
quick.
5 people watching. So if you think of any other questions online, we'd be happy to answer them for you. There may be 1 or 2 more people floating about over here that we try to pull in and interview on the live stream.
Mhm.
There's a lot of people walking past because we're kind of on the path to the restrooms for people who've been
The
working out in the
t-shirts,
field
right?
all day.
Oh,
Yeah,
the t-shirt.
and the t-shirts. Yeah.
People did see that t-shirt sales were going well.
Yeah. Yeah, so we're gonna see if we can get Robert Stubblefield, who's one of the site managers here. He may be too busy to talk to us, but we're gonna see if we can get him on.
I can move.
Yeah. Yeah, Robert, do you have a few minutes?
Yeah.
Okay, I'd like to interview
Oh
for
my
a live
God,
stream.
yes.
Yeah. And if is Karen around too, or
Yes, let me get her.
Okay, yeah.
Let me get
So
her.
we're gonna get Robert Stubblefield and Karen Lopez, who are the people that make this site work and make it function as it is, and have been doing so for. First time I was down here was for a conference I had here in 2017, and they were running the place back then. A bunch of things are a lot nicer now than they were then. There's been a lot of nice improvements. Turn around a little bit. You can see we've got a bunch of renewable power on the site here. You can see a big solar panel that people have also realized makes a nice shade tree of sorts. And I think the windmill is blocked right now. But there's a few windmills. There's a lot of solar power here.
Oh, in the building, there's
Yeah, the building's covered in solar panels, but I don't think I can get that on this camera
Yeah,
very
okay.
easily. Yeah. Yeah, so I think sunspots, an interesting thing about sunspots also is that they were actually discovered by Galileo Galilei mainly because he was the first person who realized that it might be interesting to point a telescope up. Telescopes that existed for a little bit before Galileo. It sometimes said that he invented the telescope, but he really invented the application of using the telescope for astronomy. Before that, people sometimes used them for nautical, military purposes.
He's the first one who pointed it up into the sky.
Yeah.
Specifically to study,
yeah.
because he was curious.
Yeah, and he also basically blinded himself looking at the sun.
Correct.
There are some ways that you can get good images of the sun without looking directly at it. There's some projection screens that I've seen a few people floating around with, and I think they're not too expensive. And so if you kind of find these sunspots interesting, you can go online and you can find some ways that you can buy some reasonable price equipment that you can use to look at sunspots that basically just shines the sun through a lens onto a screen, and then you look at the screen rather than looking directly at the sun. Do you know some more about those, Sienna?
No,
Okay.
But
also the,
yeah.
but the filters.
Yeah.
Yeah.
Okay. Yeah. They filter them too. Yeah.
Yeah, but you can also get filters for.
Oh, yeah.
For telescopes, binoculars.
Yeah. So like I have these solar binoculars. They're a little bit hard to point, so we didn't have that much luck with them today. But
Actually, I didn't try them.
Okay.
Let me try them now.
yeah, let's see. Yeah, you're better with binoculars than
Not
average person out
necessarily,
here.
So
Caps are on now, so that definitely.
these are definitely solar, right? They
Yeah.
definitely have
Yeah,
their
yeah,
filters on?
Yeah.
Oh,
Yeah,
great.
those are the filters are built in.
Great.
Yeah.
And one very important thing with solar filters is they always have to go on the optics of your instrument, not between your eye and the instrument.
Okay.
So that's something.
He's staying here.
Okay.
He's out and about. In fact, I'm not so sure he's not inside.
Okay.
People-
Yeah. So
they were crunched
yeah,
down
you can
and,
Google around and try to find solar projection screens if you're interested in looking at sunspots. This is actually another area where amateur astronomers actually help quite a bit in keeping track of sunspot numbers with time, because understanding that helps astronomers understand how the magnetic activity cycles inside the sun work.
Cool.
Yeah. What do you get? Yeah. And if you want a sky and telescope sticker, you can get that too.
Aw,
Um,
we tried to do some work with you guys quite some time ago. Are you still out of like Wisconsin?
No, sorry, we're from Texas Tech. She works for Sky and Telescope. She's the observing editor. Yeah, okay. Yeah, you're better at pointing them than the rest of us.
Is your office still up near Apple?
We'd like to have you all talk to some of the people back in Lubbock about the Junction campus and what you all do here. Yeah, so this is a beautiful site here. And I was saying a whole bunch of stuff has been improved since the last time I was there 7 years ago.
Yes.
It's because you all have been working very hard to make this a great place. So this is Karen Lopez and Robert Stubblefield, and they both work here full time. I think Karen's out of the picture.
There we go.
Yeah. So maybe you all can tell people what goes on this site when there's not a solar eclipse happening, and why it's so important that we keep maintaining and improving the site.
Okay, well, if I may, just a little bit of start off.
Yes.
You know, number one, the Technical Center in Junction has been there for 53 years. And throughout the calendar, we have a number of events that have professional organizations that utilize this for either strategic planning meetings, retreats, all education component, you know, with presentations, what have you. One of our signature programs out here is our Outdoor Learning Center. And we get predominantly 5th through 8th grade that come out here throughout the calendar, all receiving STEM-based curriculum, 3-day academies to 1-day excursions. Since its inception, we've had a little over 40,000 kids that have been on the property. Karen, talk a little bit about the academic.
Yeah, we have an academic program. The college students from Lubbock come down here and they take classes during an intersession. It's a 15-day intensive. And they can earn 34 credit hours depending on the course during that time. So it's very intense, hands-on, out in the field, day and night. And they stay here on campus, they eat here on campus, they get up and they go to school and out in the field, out in the
Yeah.
river or wherever.
Sure.
So
And it's
Yeah.
mostly kind of outdoor
it's
type
all,
education.
yep,
Yeah.
pretty much all of it.
Nobody wants to have a class here just to keep the students away from the distractions.
No,
Right.
no.
Uh,
Our claim to fame is it's all hands-on,
Yeah.
whether it be at college level or at the middle school.
Mhm.
And that's kind of our signature program.
Yep.
Again, one neat thing we also have with the K-12 program on main campus is we have a really strong connection with the Brazilians.
Okay.
And so every year we have the Brazilians come in, they'll spend some time with us. We've had as many as 178 Brazilians here at one time, and they're all basically in parallel with what they're doing there. They receive a high school diploma from Texas Tech.
Okay.
And then, in part, they're going to end up going to Texas Tech for higher education. And I have to say, what was it you said 7 years ago when you were here you brought in that group of astrophysicists from all over the world and stuff.
Yeah.
And one thing I remember Tom saying is that I'll see you in 2024.
Yeah.
And I thought, for
What?
what? He said the total solar eclipse is coming your way and we will be there. And so Tom, thank you so much, guy.
Well, thank you both for keeping
Yeah.
the
Yeah.
Alex
you bet, you bet,
Absolutely.
Tom.
Yeah.
All right. Thank you, Tom.
Okay, thank you both.
Okay.
Yeah.
Bueno, thanks.
Sorry? That's Deanna's from Sky and Telescope, and we're from Texas Tech. Yeah. 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 And you're from Exploratorium?
Yeah.
Yeah. Okay.
You're the artist.
Oh, you're the artist. Okay. Yeah.
Remember,
Right.
you're the storyteller.
Yeah.
Right. Okay. Yeah. Okay. Now I got it. Yeah.
Um,
Yeah. I've met enough new people here. They're all kind of blurring.
They're starting to mention.
Yeah.
How was your?
It was good. Yeah. Yeah.
We got the darkening.
I would,
Yeah.
I won't drive there and I'll have my,
Yeah.
tornado over. The big moment.
Yeah.
Yeah, I know.
Yeah. I wasn't
Here
quite,
10
I
minutes later.
didn't have the exact time written down, and I wasn't quite sure when the totality started. But at some point it was clear it started. Yeah.
Perfect, and I know that, as soon as we
Yeah.
get, kind of a idea, we're gonna.
Yeah, it's
have the
interesting.
Track over here, we changed our ports on and took it off the skids here.
Yeah,
put it
yeah.
On the track. That way we get out here,
Yeah.
boom. That's
Also,
the
it's nice that
PCC.
there's,
Yeah.
when it was a sliver, you could look at it with your naked eye.
Oh, yeah.
Sometimes it's nice.
Yes.
Okay, so we're getting another question here from Active Learner again saying, you were saying sunspots. There are some lines and a semicircle in the center of the sun. Are they different?
Oh,
Okay, so this,
that was probably from the NASA one.
I know what this is really zoomed in right now on the
Oh, I can't
sunspots.
see it.
Oh,
Okay, and I get some dust on my screen from the wind blowing all day. And this is a touch screen, so we'll see how that does with getting rid of
Okay,
it.
I
Yeah,
see.
okay,
yeah, you see those
Okay.
lines and yeah.
yeah.
Mhm.
Okay, so let me think how to explain this. Can you explain this? This is zoomed in on the different parts of the sunspot.
Are those the plages, what they call the
Yeah,
plages?
I think so.
Areas, they're lighter areas.
Yeah.
I'm not very familiar with them, but they are related to, various magnetic activity.
Yeah,
If they're
so
lighter, I think they're at a different depths. Something like that.
yeah. I also wonder if that might have been a polarized image, but
Okay, yeah.
but I'm not sure. Yeah, so unfortunately, none of us are solar
Right.
physicists who know the gory. Some of the solar physics gets into some gory levels of detail, because there's certain things that you can only look at on the sun and not on any other stars.
Mhm.
And that kind of stuff, people who really know it tend to be people who work on the sun, and the rest of us understand how stars work, and sometimes don't know all those little details. Let's see if we can Google that though.
Well, just, if it is a plage, then I'm Googling, because I can't remember exactly.
Yes. I think that might have been an H alpha image.
Okay.
Oh.
Yeah, filaments and plages. Yeah. Okay. Yeah, and also some of the stuff that you see with the sun, it depends on which angle you're looking at it from. So like if you have a sunspot, and then you put it on the edge of the sun, sometimes you see loops coming out. And if you were seeing that rotated so it was on the main body of the sun, you wouldn't notice those loops.
Yep.
Um,
Collages are best seen in hydrogen alpha, which
Yeah.
is what you were saying, and
Yeah.
they're associated concentration magnetic fields, as
Yeah.
you said, it's magnetic activity.
Yeah.
Concentrated magnetic activity in
yeah.
best seen in hydrogen alpha.
Yeah. Okay, so hydrogen alpha is the wavelength of light you get when electrons move between the second and third energy levels in a hydrogen atom. And that tends to be a useful line because it's invisible light. The stuff that goes down to the ground state of hydrogen is all ultraviolet. So then you tend not to be able to see it without very specialized equipment that actually has to be in space.
And the junction feed, you could only see that one sunspot.
Yeah. But then when they jump to the other one, right? This is a little bit, my video on the screen here is a little bit ahead of what's on the live stream. This is just a lag going to YouTube Live.
Oh,
You
yeah.
can see,
the
yeah, and you can see that those filaments are in the same place where the sunspot was before,
Mm-hmm.
right? And so this is just probably they moved to a hydrogen alpha camera, and so you see different aspects of the region around the sunspot. Okay, so I hope we sort of answered your question there. And that's something that if you email one of us afterwards, we can look into it in a little bit more detail and answer it offline.
And did you say that did you mention that some of these bright streaks might be filaments that we're seeing directly above?
I didn't mention that.
That's
but,
another, that might be another explanation, that it is a filament which would be like an arcing or a loop, like a bit of a material coming up. And often we see it from a bit of an angle, so you see the actual elevation of the plasma of the material. But sometimes these bright streaks we're seeing them directly from above, perpendicular.
All right, and we're starting to get towards the end. I don't know how much
Yep.
longer we have, maybe 15 minutes or so.
Yeah.
I had the
What time is it? 2:41? Yeah, it's probably like 15 to 20 minutes.
How's it going? How did it
Good.
go for you?
When we were out there, we were having trouble getting on the Wi-Fi, but as soon as we moved over here, everything was great. How about for you all?
Best as we could.
Okay. You want to tell some folks in Lubbock, Texas, what you all were doing, or you're gonna run? Okay. Okay.
Yeah, we have 14 more minutes.
Yeah. So we got about 14 more minutes.
For the time and date, it says 2:55 is when it ends.
Yeah. Yeah.
Oh,
Yeah. Deanna just looked that up also. Yeah.
So what's that? Oh, yeah. Like,
Yeah. About 14 minutes. Yeah.
Mm.
Yeah. Okay. All right. I think I'm going to take a break and go look through solar glasses. Once again, if you want to join a club back in Lubbock, South Plains Astronomy Club.
Yeah, and it's cleared out a lot since totality.
Totality.
Yeah, because you could see the
Some of the young
Big
ladies
clip.
have I'm sorry.
oh, you're totally fine.
No, you're fine.
They're working on the video, of course. Each one I'm kind of has a phenomenon that goes along with each phase or stuff like that. And it was included by the clouds and stuff like that. So they were looking to see if they could talk to somebody that knew a little bit. We could be willing to speak to a few of them. I could bring them over here. They're video recording, so they may want to record you talking and stuff like that. Is they okay? Let me grab them.
Back on.
Okay, I'm gonna grab it.
Yeah, Brett, we're happy to go in the classroom after everything's over too and answer whatever questions they have.
So they're part of the project that they're here, they're producing a 1 to 2 minute snippet of some effect, and it kind of documents why they're here.
Okay.
And so they were kind of bummed that they didn't get to see that part, but I said maybe there's somebody that can talk.
Yeah, we got it recorded too. Yeah.
Hey,
Yeah, my sister sent me a pic of it in Arkansas.
Okay.
Yeah.
Nice.
Yeah.
Okay.
It's like perfect.
Yeah.
Looking one. Yeah.
Oh, your sister went to Arkansas?
She lives in Huntsville.
Oh, okay.
Yeah.
Oh, okay.
Yeah. So she just drove over there.
All right. Yeah. So now this is an extreme zoom in here. And I'm pretty sure this is in the hydrogen alpha filter.
Yeah.
See a lot. Like lines. Oh yeah, there we go.
Yeah. Okay, and so we may have in a few minutes we may have some student from the Talkington School for Young Women Leaders in Lubbock, who have some questions that they're gonna probably ask mostly to Deanna about some of the things that they were hoping to see but didn't get to see because we had some cloud cover here.
Nice to meet you.
Hello, nice to meet you. My name's Nadia.
Nice to meet
So
you.
they're part of the school talking to the their project that they're working on explaining the phenomenon. But they did not get to see this phenomenon. So we have one question and they would like to, and I'm taking away your time. We tell them what you want.
Maybe we can get out of the sun. Now it's almost at the end of the eclipse.
Yeah.
So it's like bright again. It's bright.
Do you mind if
I don't mind it. Where did you ask one question?
So right here, you could see some darker regions and then some
Yeah.
brighter regions. What are the brighter regions? You know?
This is one of these things that I used to know, and it's been a while. I should have found some time to look up some of this stuff ahead of time. But
yeah, because I haven't seen that much in this filter, so I don't.
But I think often there's almost symmetric relationship between the bright and dark parts of the stuff, but then some of it goes up and some of it goes down, so that some of it gets a little hotter and some of it's a little bit cooler. But it's been a while since I really dug into that stuff. Yeah. Yeah, and you know, folks watching at home, this is how science works. We don't all know everything all the time.
It's not a
yeah.
Marvel superhero movie where
Yeah.
they're an expert in every area of science.
Yeah, yeah. Yeah, we have to look up a bunch of stuff. So we try to, you know, when we teach students, we try to make sure that they understand principles so that they can then apply them, and they, you know, memorize enough facts to make the principles fit together in their heads. And then you know, you don't need to remember all the numbers. You go look them up and they make sense to you, and you can usually figure out if you've got the wrong number because you know roughly what something should look like.
Yeah. Oh, nice. That's fast. Oh, I think they're gonna ask you another question.
Yeah, they seem to be coming back.
Oh.
Yes. My name is Diana, Diana. And I have to spell my last name. Okay. H-A-N-N-N-N-I-K A-I-N-E-N. And now we're done.
Oh, what? How do you say that?
It's exactly the way it's written, Honeycomb.
Oh,
There are no weird
Honeycomb.
letters, Honeycomb, perfect, yes.
Where does like it originate?
Finland,
Oh, that's fast.
yeah.
That's cool.
Well,
I have a complicated last name.
Oh, you do?
Yalawalo.
Right, so you're also always spelling it to everybody, right?
Yeah.
Yeah.
Like whenever we have like presentations, we'll be like, oh yeah, Charlie did this. Everybody always does it.
Yeah, I have that too. The students, half of the students only call me Dr. M.
Oh yeah.
Yeah.
Well, thank you. Thank you so much.
Sure.
Anyone with the
I wish I could have been a little. bit more-
No, we're with main campus at Texas Tech. I don't know. I think the people in the office are the people with the local campus.
All right, we wanted to see if we could buy an armadillo.
Oh, okay. Yeah, I'm not sure. I'm not sure about that. Oh, wait. Oh, sorry.
Yeah.
Didn't see you over there.
I think they mean like stuffed armadillo.
Yeah, I know that.
Oh,
Yeah,
okay.
yeah, I'm sure it's yeah. I don't think they sell live armadillos to people passing through.
Yeah, that's what I was like. Oh,
Okay, and I'm not. Are we? No, we should still have a few minutes left. I think.
yeah,
We're just having a little technical glitch, I think. Oh, no, they may be packing up over at. No, we're back on.
Still there?
Still there.
maybe it's some.
Maybe it got a little patch of cloud. Looks like it's gotten a little cloudy there.
like the last 5% of the eclipse. Yeah, there's definitely some cloud coverage.
Yeah.
but Yeah, we're coming up towards the last little part of it. Oh yeah, it looks way bigger here. I mean, obviously it's on the telescope.
Yeah.
Yeah, a pretty nice day overall.
Yeah. Yeah, and I think, like you said, a total eclipse in the clouds is still a bigger deal than a partial eclipse in the clear. Yeah.
Oh, the onset of darkness was
Yeah,
was quite
yeah,
magnificent.
yeah.
Uh-huh.
Yes.
I think there was some light scattering off of clouds, and it wasn't quite as extreme as I remembered it when I was in Idaho in 2017, and it was clear there. Like there was nothing in the sky there.
Yeah,
But
yeah.
yeah.
Yeah, I guess they're setting up the telescopes last, just so we get, yeah,
Mhm.
but it does look like they're setting up stuff.
Yeah. Okay. Yeah, so we're going to sign off as soon as the eclipse ends here. But if you're interested in this, if you go to the NASA live stream, they're going to keep following the eclipse up towards the northeast, and I think it's got a little bit of time to go before it's over in the places up in Maine. And I'm pretty sure NASA does have a telescope up in Maine.
They just set up telescopes throughout the whole path of totality ahead of time.
Yeah.
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 They didn't want to risk it with the weather.
Yeah, I think also they like to get more communities involved.
Yeah,
and if
I mean-
the weather's good, and they also they can make their broadcast last longer if they go
If they have
everywhere.
it throughout the whole thing.
Yeah, and they're probably doing some of what Deanna was talking
Yeah,
about,
but-
also that they
Measuring the corona.
measuring the corona changing over time. Yeah,
Yeah, that's pretty cool.
yeah.
I mean, we have 8 people right still.
Okay.
Still good. Sizable.
Yeah. Yeah, and we'd like to thank you all for viewing. If you're local in Lubbock and you want to come to some of our public events, we've been really busy this semester and in the fall with eclipse planning and doing eclipse-related events and a bunch of other stuff going on. But we're going to try to pick our public events up soon. In the summers in Lubbock, between daylight savings and being on the west edge of the time zone, the sunset is really late. But what we can do is we can set up some solar telescopes so that people with kids can observe before it gets to be, bedtime. And we'll try to have some of the same science demos and some new science demos and some public science talks and things like that. Okay. So, right, and I'm not sure what's going on now. We're just getting blank screen, but
It might be. I don't know if it's just wrong.
okay. Oh, okay. All right. It's just cloudy in front of the sun right now. Yeah, I guess I can kind of tell that from here because
Few
it's
minutes
a
to
little
go.
bit cooler. Yeah.
Yeah, it's
Yeah,
getting
just a
cooler.
couple minutes left. Okay, so if anyone listening online has any last minute questions, kind of last chance in the next couple of minutes to ask them. But if you think of any kind of astronomy questions that come up in the meantime, just go to our Facebook page or send me an email. I'm going to put my email in the chat. So you can go to our Facebook page or you can email me and I'll add you to our email distribution list about our public events if you're not already on one of those. And then, if you come to one of our public nights, you'll have opportunity to go all around our department and ask different people all what the questions that you might have. And chances are one of us will be an expert in whatever you're interested in.
And if you want to learn more about astronomy in general, subscribe to Sky and Telescope magazine. You can always go to our website. We have we post stories on science and observing and all of that, skytelescope.org. But once a month, you'll find a nice, nifty little magazine in your mailbox if you subscribe with all the cutting edge science and observing tips that you could ever want.
Okay, thank you.
1 minute to go.
Oh, I don't think you can.
We may end on a cloud.
Yeah,
but,
it might end. You won't see it. Nope, right? It's cloudy. Yeah,
nothing. Yeah.
yeah, I think it's totally covered up. I mean, we didn't get any rain, so that's good.
Yeah.
I think it was supposed to rain like around 2 something.
There was some risk. Yeah. May rain later, but yeah, some of those clouds off there
Yeah.
to the, I don't even know what direction I'm looking right now.
And the horizon over there looked pretty dark, like that one over there.
That's probably south. 'Cause I'm just thinking which way the sun's been going all day.
Oh, yeah.
Yeah.
And technically it's over.
Okay. All right. So the eclipse is over here in Junction. So we're going to shut down. We hope you enjoyed our program. And we hope that you find a chance to make it out in person to a solar eclipse sometime where you are. Next one in the US is going to be in Alaska in about a little less than 10 years. Next one in the continental US is going to be I think 2044. Yeah.
But 2045 is the next one that'll cross.
Okay, yeah. So 2045. So as long as you're not too old, you should have another chance in about 21 years to have one that'll come through the main body of the United States. Okay. All right. Bye, everyone.
Bye.
Bye. Oh, sorry.
Bye.